Google's yet unreleased Gemini, short for Generalized Multimodal Intelligence Network, is set to bring about a new era of AI capability by processing 6 or more data types to enable future innovations, like memory and planning. But Gemini's innovation doesn't stop there, because unlike traditional models, Gemini isn't just one model, but a synergistic network of multiple separate AI models that work in unison to handle an astonishingly wide variety of tasks. But how does it work, and does it beat OpenAI? Part 1. Gemini's architecture. Interestingly, Gemini's architecture brings together an encoder and decoder that work hand in hand to create a common language that operates along the following 5 steps. Step 1. The user provides inputs in various formats, allowing unparalleled flexibility. Step 2. The encoder transforms the different data types into a unified representation, translating them into a language the decoder can interpret. Step 3. The model works task-agnostically, meaning it processes the encoded inputs without the need for specifics about the task. Step 4. The decoding stage involves taking processed inputs and generating outputs in different modalities, tailored to the user's needs. Step 5. Finally, the outputs are generated and are returned to the user. As a result, Gemini is expected to far exceed the abilities and understanding of even GPT-4, being able to learn from any domain and dataset without needing specialized models or fine-tuning, which stands in stark contrast to existing large language models. The first reason for such a huge competitive advantage is Google's edge on data. Part 2. The data advantage. Google has scanned over 25 million books, equating to an estimated 2.5 trillion words. Furthermore, with over 800 million videos, their YouTube dataset is a treasure trove for training vision-enabled language models with tens of billions of minutes of video with transcriptions. Also, Google's extensive scraping of the internet to power its search engine is reportedly in excess of 100 petabytes, easily translating into the 2 trillion word range when filtered. Because of the vastness of Google's data resources, the idea of expanding Gemini's training set to 5 trillion tokens is not far-fetched, with such a dataset dwarfing GPT-4's believed 1 trillion tokens and allowing for unprecedented scalability. Additionally, these figures exclude conversational data generated with Google's Bard or Anthropic's Claude, likely bolstering the training set even further. Google's technical paper also emphasizes that scaling model parameters, dataset size, and quality will continue to improve the performance of large language models. Part 3. Enhancements. Beyond sheer volume, Google also stresses the importance of architectural and objective improvements, claiming that this multifaceted approach ensures the training is not just about quantity, but also quality. Plus, although access to the final trained system may be restricted due to inference costs, Google likely plans to distill its knowledge to smaller, more cost-effective systems, intending to bring the immense capabilities of Gemini to a broader audience. Google also mentioned that models range from gecko to unicorn, with Gemini offering 4 different sizes in total, even working on mobile devices and offline. What's more, unlike conventional AI models, Gemini possesses the remarkable ability to generate genuinely novel outputs. Whether crafting a story, a piece of art, or music, Gemini can actually create instead of just mimicking its original training data that it was built on. Part 4. Gemini's capabilities. Additionally, Gemini is slated to include the following 5 capabilities. Ability 1. Multimodal question answering, using multiple data types, whether text, image, or video. Ability 2. Unparalleled summarization of text, audio, or video content. Ability 3. Translation going beyond language translation, with Gemini also being able to translate between different data types. Ability 4. Generation from essays to images, music, and possibly even video. Gemini will be a truly versatile tool for creators. Ability 5. Gemini's reasoning ability when combining information sets it apart, making it an essential tool for problem-solving and decision-making. And these are likely just the tip of the iceberg when it comes to functionality over the long term, because the Gemini is also expected to continue learning and improving after its release. It's also expected that Google will launch its own AI plugin marketplace, allowing third-party developers to also contribute to Gemini's expanding abilities and intelligence after its launch. Part 5. A possible glimpse at Gemini. Following the anticipation surrounding Google's Project Gemini, the tech giant's AI research subsidiary, Deepmind, has just unveiled MedPalm-M, an all-purpose AI medical expert representing a groundbreaking evolution in medical AI models, capable of processing text, medical images, and even genomes for diagnosis. Notably, MedPalm-M has its foundation in Palm-E, Google's cutting-edge robot model that melds language and vision. Unlike MedPalm-2, though, which was focused solely on text, MedPalm-M's evolution embodies its ability to analyze visual data. Just as MedPalm-2 refined the foundational language model Palm-2 with medical data, MedPalm-M follows a similar trajectory, becoming a specialized variant of Palm-E enriched with medical insights. Part 6. A Universal AI Doctor. Importantly, Deepmind says MedPalm-M is a step towards a general-purpose biomedical model, a universal AI doctor capable of diagnosing and understanding a myriad of medical topics and images. And MedPalm-M's versatility is truly remarkable, as it can answer complex questions akin to MedPalm-2, plus delve into X-ray images or scan DNA sequences for mutations. Across various disciplines, MedPalm-M not only competes with specialized systems, but even redefines benchmarks in fields like X-ray diagnostics, where to evaluate MedPalm-M's capabilities. Deepmind's research team developed Multimodal Bench, a multimodal benchmark comprising 14 tasks from 7 medical disciplines. This includes over 1 million examples to foster biomedical AI development. MPM's proficiency in diagnosing chest X-rays become apparent in tests, with clinicians preferring AI-generated reports in roughly 40% of cases. Its clinically significant error rate aligns with human expertise, making it suitable for clinical application. Part 7. Extras. One of MedPalm-M's most intriguing features is its zero-shot capability, enabling it to recognize and describe new medical phenomena without prior training. This attribute could revolutionize cases where example data is scarce. And while MedPalm-M represents a monumental advancement, the Deepmind team recognizes the need for further development. Primarily, the challenges lie in scaling high-quality and occasionally rare data and broadening benchmarking, as Multimodal Bench still has limitations in its scope and the variety of tasks. Altogether, MedPalm-M is an important step toward general biomedical AI and soon artificial general intelligence. And as we await the arrival of Gemini likely later this year, it's clear that this next generation of large language models will tie together diverse sets of knowledge into a single, coherent system. The coming potential to set new standards, adapt to new tasks without prior training, and integrate diverse medical knowledge seems to indicate that Google is getting closer and closer to achieving general intelligence across domains. And with Gemini successfully tackling the fusion of such a variety of data types and tasks without relying on specialized models like MedPalm-M, it also marks the beginning of an unparalleled shift in workplace automation and synthetic production, as Gemini can abstract its understanding far beyond the confines of its training data to learn to generalize at a level that was previously unattainable, even by the likes of OpenAI and Microsoft, securing Google's near-term future in the rapidly changing artificial intelligence landscape.